So, welcome to our live training session on shooter mechanics. I'm Matt Shell, aka Matt Marafish on Twitter, and I'm going to be with you for the next hour. We're going to talk about two popular methods of shooting in video games. The first is a raycast or hit scan technique, and the second is a physics projectile technique. So we're going to do a kind of a laser gun for the raycast technique and a grenade that you launch into the scene for our physics projectile. So let me just, you should be seeing the Unity editor now on the stream, and I'm going to play my demo scene, show you guys what we're going to see, and then we will open up a starter scene to do some scripting. So here we have a first-person character controller with a gun attached. We have a little reticle that I made with the UI system, and we can left-click to shoot our target man, and if we shoot him 3 times, he disappears. So when we shoot, we play a sound, we see a little muzzle flash, we also see this pink laser line and some particles that appear where we shot. We can also shoot these little guys, and you can see they get knocked around a little bit. We're adding a little bit of force to them. We also have our, if we right-click, we have a grenade that can do damage and also bounce things around. And you can see that in this case, we're turning the cubes red, and that's because we set up a interface so that we could have different behaviors when we shoot the man and he takes damage, and when we explode the cubes with the grenade and they take damage. And we'll walk through that and talk about how that works. So there's no assets recommended for this. I'm using the VR samples project, which is where this content comes. It's free on the asset store if you want to grab it. But really, this is more about the principles than recreating this little scene. So I would just say sit back and enjoy the training. So I am going to open. I have a scenes called starting scene, where actually here, I'll just show you how it's set up in the demo scene. So here we have an FPS controller. There you can see it. It's got this disembodied arm as a child of it, which is here. And then, there it is. And then on it, we have an audio source, which plays the sound, a script called Raycast shoot, which does the laser, a script called Projectile, which launches the grenades, and then a line renderer, which draws the laser line. And so let's open up our starting scene where I've taken those things off because we're going to recreate those. All right, so what we're going to do is we're going to add, here I'm going to highlight the gun, and I'm going to click Add Component, and I'm going to type Raycast. Now notice I already have a script called Raycast shoot, right? That's from my demo scene. So I'm going to call this one Raycast shoot script, just so we don't have 2 scripts with the same name and have a conflict. And then I'm going to hit create and add to add it directly to the object, and double click it to open it in my script editor, which in this case is going to be MonoDevelop. So you can follow along in Visual Studio or whatever other script editor that you like. I'm just going to zoom in so you guys can see. Okay. Pull up my notes here. All right, and before I begin, I'm just going to say it looks like I am flying solo this afternoon, and so I do not have anybody helping me with the chat. So I will check in with you guys in the chat in a minute. Please try to keep it focused on the topic of hand. I don't have time today for off-topic conversation. If you have a question about something else, save it for the end, and I'll do a little Q&A at the end where we can answer some other questions. But I'm just going to go through my content, and I'll take some breaks to check out the chat and answer some questions there. So what we're going to do is we're going to start in our raycast shoot script by declaring some public variables. The first variable we're going to declare is going to be a public variable of the type float, which we're going to call fire rate and initialize to 0.25. This is going to be 0.25 of a second, so a quarter of a second, and this is going to be how often the player can fire. Next, we're going to have a public float called range, and we're going to set that to equal 50. That's going to be when we cast our ray into the scene, how far is it going to go? We're going to have a public particle system called smoke particles. This is going to correspond to, if we look at our gun, it's got a little child object, which are these flare particles. You can kind of just barely see them there. Whoops. They just give off these little kind of smoke dots. Let's see if we can get a better look at that. There we go. Ooh, that was actually pre-made in the VR samples shooter scene. And so we're going to play those. We're going to have our little smoke. We're also going to have a public variable of the type game object called hit particles. And these are going to be the particles that are going to be spawned where our raycast hit. And we're going to have a public game object called shoot flare. This is just our little muzzle flash, which we'll see. There are actually 3 of them. We're just using one, which is a child of the gun, and we're just going to turn that on and off to have our little muzzle flash effect. Then we are going to have a public integer called damage, and we're going to initialize that to 1. That's the amount of damage we're going to deal when we shoot the enemy. And then we're going to have a private variable of the type camera called FPS cam. And the camera is attached to the first-person character controller, and we're going to get a reference to that and store it there. Next, we're going to have a private line renderer called line renderer. The line renderer is what draws the visible laser line in the scene. So normally a raycast is an invisible line in the scene, but we're going to use a line renderer to render it so that we can see it and make it visible, just to really drive the point home. Also, it's cool if you want to make it like a laser weapon for your game. Okay, then we're going to have a private variable of the type wait for seconds called shot length, and we're going to set it to equal new wait for seconds 0.07. So what this is we're going to use a coroutine, and this is how long the coroutine is going to wait. I'll explain a little bit more about that when we get to the coroutine. We are going to have a private audio source called source. This is going to be the source that plays our shoot sound. We're going to store a reference in there. And then we're going to have a private float called next fire time. And this is going to be, once we've fired, the next time that we'll be allowed to fire again. And we're going to set that using fire rate. Next, we're going to declare a wake function, and in it we're going to get a reference to our different components. So we're going to say line renderer is equal to Getcomponent line renderer. Source is equal to Getcomponent audio source. And FPS cam is equal to GetComponent in parent camera. So what we're doing, because the camera is not actually attached, I'm just going to save and jump over here. So here's the weapon, right? The gun, which has our script on it. The camera is not on this object, so we can't do GetComponent to get a reference to it. But if we do GetComponent in GetComponent in parent, it will search up the hierarchy. And in this case, the parent of this object does have a camera attached, so it'll find that and store a reference there. Kind of useful. Okay, now we don't need start because we're not using it. And in update, we are going to do our shooting code. So the first thing that we're going to do is we're going to declare a variable of the type raycast hit called hit. So the raycast hit is really important in this example because the raycast hit, normally if we cast a ray into the scene, right, we're casting an invisible line into the scene, and when we hit something, or if we hit something, it will return true or false. So true if we hit something, right, within our range of 50 units, or false if we didn't. Using a raycast hit, we can store a bunch of additional information about the thing we hit, like its collider, its rigid body. We can get references to scripts that are on it, and we could do a lot more with it. So because we're going to want to interact with the things that we're shooting, we are going to store information about them in our raycast hit called hit. Next, we're going to declare a vector3 called rayOrigin and set it to equal fpscam.viewport, viewport to world point. And we're going to set that to a new vector3, which is 0.5f, 0.5f, 0. So what this is doing, if we look at our camera, we can see, with the camera highlighted, we can see the camera has this kind of trapezoid box, right? And what that's called is the View Frustum. It's kind of a funny term, but that's what it's really called. And so we can see here, this is what's called the near clip plane of the camera. And it is this flat rectangle. And this is actually corresponds to what we see as we look into our game world, right? So this is a flat plane that exists. It's a 2D plane that exists in our 3D world space. So using viewport to world point, what we can do is we can get a point on the viewport on that near clip plane and translate it to 3D world space. So in this case, we're doing 0.5 on the X, 0.5 on the Y, and 0 on the Z. So in this case, it's going to be halfway across, halfway down, which gets us right to where I have this reticule, which is the middle of the camera's near clip plane. Okay, so we're converting that to, and then the Z means it's 0 units away from the camera. It's right at the camera. So we're getting a point in the middle of the camera, and we're going to use that as the origin for our ray. Now we're going to cast our ray into the scene. So we're going to check, first of all, if the player has clicked the left mouse button. So we're going to say if input.getButton down, fire 1, and double ampersand, time.time is greater than next fire time. Has enough time elapsed since we last clicked fire 1. If that's true, we're going to set next fire time to equal time.time plus fire rate. So we're saying, okay, we successfully fired. Oops, I got an extra parentheses here. That's why I was like, wondering why is this showing red? There we go. So we're going to add 0.25 seconds to time.time and then wait until time.time is greater than next fire time before we allow the player to fire again. So it's just a way to make sure that the player can't fire every frame or just spam the fire button as often as they want. Okay, then we're going to cast our ray. So we're going to say if physics.raycast rayOrigin is going to be the origin point, right, where we're casting from. The direction that we're casting towards is going to be fpscam.transform.forward. So the forward direction away from the camera. Then we're going to specify hit with the out keyword. So what this means is the return type, the return type for physics.raycast is a Boolean, right? Saying true or false if we hit something. In order to get additional information out of this function, we're using the out keyword and storing that information as a reference in hit. Then we're going to specify range, which is the range at which we're going to cast our ray. Okay, so if that's true, meaning our raycast hit something, we're going to do the following. We're going to say enemy health. We're going to declare a new variable of the type enemy health called damage script. And then we're going to set that to equal hit.collider. So now I'm using our raycast hit has a variable, has a field called collider. And so now I'm going to say, okay, I want to get the game object of that collider, and I want to get component to access the enemy health script that may or may not be attached to that thing that I just shot. Now, I'm going to check if damage script does not equal null, meaning there actually was an enemy health script attached, and we grabbed it and stored it in our damage script variable, right? So if there wasn't an enemy health script, damage script would equal null, and that way we can check if there is a damage script. Now, this idea here is a really crucial one, right? Where we're using the hit to get another script, right? This is the way we're going to access another script in the scene that wasn't set up in the inspector, or we're not using GameObject.find or any of that stuff. We're casting a ray against something and then getting a script from it so that we can do more stuff with it. In this case, we're going to use it to deal damage. So now we're going to say, okay, if damage script does not equal null, meaning we found a damage script, we're going to say damage script dot damage. And so we're going to call the damage function, and we're going to pass in damage. And we're also going to pass in a vector 3 called hit point, which is going to be equal to hit dot point. So this is another of the variables that we have in raycast hit, which is point, which is a vector 3, the point at which the ray struck the other object. So we're going to pass in damage. That's how much damage we're going to do. And we're going to pass in hit dot point because we might want to later spawn some custom particles like some blood or sparks or whatever from the object that we hit. And so we're passing in hit dot point so that we can do that, so that our damage script can know where it was hit. Okay, so now let me just do a quick test, because this is the most minimal and basic version of our shooting script, right? Where we're just going to cast the ray and do damage. Let me just jump over and test to see if that's working, and I will check the chat and answer some questions. I've got a typo. What did I type wrong here? Physics.raycast, ray origin, out, hit. Oh, range attribute. No, that's not what I meant. There we go. See, there's that autocomplete for you. Okay, there we go. Autocomplete for the win. There we go. All right. So now we're not going to play any sounds or show any effects, but 1, 2, 3. He disappears, right? So I click 3 times with my reticle pointed at him, and he dies. So we can see that that's working. And I'll take you through the enemy health script. It's super simple, but I'll take you through it a little later on. Basically, the damage script just takes away the amount of damage each time we shoot it. Okay, let me take a look at the chat and zoom through a couple questions quickly, and then we'll keep going. All right. Yeah, so the question about the out keyword. So basically it passes a reference it passes the data via reference and stores it in the other and stores it in the variable that we specify. Yeah, it's pretty useful. It's basically useful when you have a function that returns one type, right? In this case, physics.raycast returns Boolean, which we are using for our if statement to check, right? So we're using the Boolean return type here to check if this evaluates to true, but that's not the only information we want to return from the function, right? So we're using out to sort of, it's not actually returning, but to sort of return additional data. Vahag1313 asks, is it right to declare the hit variable inside the update method? Yes, it is. And the reason that I'm doing that is because each time I don't want the hit from the last frame. If I had like a global variable called hit, it would be storing the data from the last thing I shot. So I want it to basically be declared new each time, and it's not a problem for performance. All right, let me just see what, we got some questions. Okay, thanks to those of you guys who are answering questions in the chat. I really appreciate that. Okay, Wolf Mountain asks, what's the difference between or and? The two double vertical lines are an or. So it's the same. If or means either of the conditions can be true, and means both of them must be true. Okay, so somebody's asking about Getcomponent in parent. What happens if you have this, Lameman 2000 asks, what happens if you have the same type in both parents and you want the first one? It takes the first one it catches. So if we're going up the hierarchy and there's a camera on this and also a camera on this, we're going to get this one because we're moving up the hierarchy and it's going to take the first one it catches. And yes, as Steak Pinball points out, it does check the current object that it's attached to first before it starts going up. So if there was one attached to this, it would get that. You can also do GetComponent in children. Similar kind of thing, but going down the hierarchy. Okay, great. All right, so I'm going to continue. All right, so that's just our bare bones interaction, right? And I want to emphasize before continuing with the shooting stuff, I'm going to put some polish on this, the sounds and the particles, right? But you could use this for all kinds of interaction, for clicking buttons in a game, or for spawning bricks, or for scanning an object to get information about it, right? This is we're just sending an invisible line into the scene and doing something with a script that's in the scene, right? So it's not limited to shooting. I'm showing shooting because that's popular, right? But this is by far not the only thing that we could do with this. Okay, the next thing that I'm going to do is I'm going to check if hit.rigidBody does not equal null. So hit also has a rigid body field, which will store a reference to the attached rigid body if there is one. So that's why I'm checking if it's null, right? Because I want to make sure there was actually one before I try to do things with it. But if there is one, we're going to say hit.rigidBody.addForce. Now I'm going to use negative hit.normal. So hit.normal is a vector that is the normal. So the normal, right, is the surface that we hit. And let's say I hit the side of this cube, right? The normal would be this face of the cube. Negative hit.normal is going to be away from the cube. So what we're doing is we are going to add force along the direction away from the normal. So we're going to say negative hit dot normal times 100. So we're going to add force in the opposite direction to push the cube away from where it was hit. Or actually, in this case, the man. Poof, poof, poof. Right? So he gets pushed over. So we're adding a little bit of force to the thing we hit if it has a rigid body attached. All right. You could also just calculate a vector from the gun to the object and add force along that vector, right? We're just using hit.normal to get a vector, which is the facing direction that the object was hit in. And then we're multiplying that to add some force. All right. Now we're going to do our line renderer. So we're going to draw our line. So we're going to say line renderer dot set position. So to draw a line with the line renderer, you have to set at least two positions. Position 0, which is going to be the start of the line. And so position 0 is going to be, oh, did I declare? Whoops, I think I left out something. Yeah, sorry, left out a public variable up here. I left out a public transform gun end. Let me just assign that in the inspector so I don't forget. So the gun end is just going to be, oh, and a parsing error. Oh yeah, because I didn't finish this. Okay, let's just finish this. Gun end dot position. So we're gonna start at gun end, and gun end is here. We can see, right? It's just an empty transform in front of the gun, and so this is gonna be the start point of our ray. And so we're gonna drag gun end to our transform variable here. Boop. All right, and next, so that's going to be the start of our line, right? And then we're going to do line renderer dot set position 1, the next position, and that's going to be hit dot point. So we're going to draw a line from our gun end position to the point that we hit. And then we're going to instantiate our hit particles at hit dot point as well. So we're going to spawn some particles at the point that we hit, and we're going to use quaternion dot identity so they spawn with no rotation. All right, let's give that a try. So I have a little particle system pre-made here for hit particles called, oops. Oh, it's compiling. Imaginatively named hit. Actually, I think this might be default particles is the one I want. Okay, and then we're also going to set our smoke particles here and our shooter weapon mesh. It's actually not doing anything yet, but I'll just show you what we have so far. Oops, what did I miss? Oh, of course, I can't show it yet. Hold on, I got to do the next part of the script. Whoops. All right, so the next thing that we're going to do, so this is what we need to do in update. The last thing that we need to do in update is we're going to start a coroutine called shot effect, which I haven't written yet. I'm going to write now. So that's going to show red because it's not written. So then I'm going to go outside of update, right? We don't want to declare another function inside of the first one. We're inside of update. And we're going to add a private IEnumerator shot effect. And shot effect is just going to do all the effects related to the gun firing, playing the particles, playing the sound, turning on and off the line renderer. Now, the reason that we're using a coroutine here is because in the middle of doing its business, we're going to want shot effect to wait for 0.07 seconds. And that is one of the advantages of coroutines, is that we can do time-based things like this, like wait for seconds or wait for another function to complete, or do loops outside of update. I'm not going to spend this lesson explaining coroutines. Look them up. They're really useful. We've got some tutorials about them on the scripting part of the Unity Learn site. Okay, what we're going to do here is we're going to start by turning on all our effects. So we're going to say line renderer.enabled equals true. Source.play, we're going to play our sound effect. Smoke particles.play, whoop, not play on awake, play. Play. Shoot flare dot set active true, so we're just enabling the shoot flare game object, and then we're going to wait. So now we're going to say yield return shot length. Now what you may have seen people do is yield return new wait for seconds 0.07 f, like this. The issue with this is that every time we call this coroutine, it's going to create a new wait for seconds object that's going to have to be destroyed and garbage collected. So instead, I've declared a variable of the type wait for seconds and created it up here, and then we're just going to use that every time. So this is our, just a little way to make our script a little bit more efficient and not allocate memory. Then once we've waited, we're going to say line renderer.enabled equals false, and shoot flare.setActive false. So we're going to wait for 0.07 seconds and then turn off the line renderer and turn off the shoot flare. So that should be good. And let's jump back over to the editor and test once it's done compiling. Oh, that's not what's supposed to happen. What did I do here? Oh, you see what I did? Look. I started the coroutine outside of the if statement, so it was firing the sound effect every frame. Whoops. Yeah. Slightly awesome, but not quite what we want this time. So what I did was I just moved the coroutine up so that it's only getting called if input.getButtonDown fire is true. Yeah. Okay. Wake up your ears, right? Okay, here we go. But my line renderer is not displaying. Let's see here what's going on. I swear this line renderer was working before. Let me just check. Enabled equals true, false, 0, 1. I think this is exactly the same code. I know. Taraka says, those are the bugs we live for. It's so true. Here's another bug that's less fun, and I'm just wondering why. Line renderer.enabled equals true. Oh, this stuff drives me crazy. This is exactly the same thing that I did before. It's on, it's casting a shadow, so I know it's, let me just make it wider just in case it's something weird going there. Oh, it's casting from the, oh, what did I put gun in the gun, I putting gun instead of gun end. So what's happening is that, and because it's flat, we can't see it. So I dragged this wrong. Oh yeah. It's always something. There we go. Pew, pew, pew. So now we can see. We can render our line, fire our laser, deal our damage, and all that good stuff. As long as we've got our things set up right. Okay, so let me take a look at the chat real quick and see how you guys are doing, and then we'll move to our next subject. bit loud, yeah. I got headphones on too, guys. We're all in the same boat. Yep. I love how the chat always knows what's wrong before I do. Gun end is wrong. Gun end is wrong. Inspector slot. Yeah. Thanks, guys. Yeah, the line could taper down. We would just change the start width and the end width. We could make the end width smaller. We could have it taper. Let me turn down the volume in that editor. I thought I turned it down already, but let's turn it down some more. I could actually turn down the volume on the source. All right, that should be better. Sorry about that, guys. Okay, so, all right, good. So let's just see. Any other questions? Wow. All right. Yeah, everybody noticed that I dragged it to the wrong place. All right. Gabriel Hoving asks, will this be covering spread? No, but what you could do is basically to do spread, you just want to get a random offset from your hit dot point. So there's a couple different ways you can do that. I can think through it with you at the end of the session, but it's not really hard to do. All right, so people talking about some other stuff. All right, that's fine. Okay, let's keep going. All right, so now we're going to move on to our projectile. So we're going to add another script to our gun. We're going to call it projectile shoot script, just so it doesn't conflict with our original. Open it up and drink some coffee. Okay, so this is actually just a short little script. We're going to, and I'll show you the other piece of this, which is the projectile itself. This is the launcher. So we're going to have a public rigid body projectile. That's going to be our grenade that we're going to throw into the scene. We're going to have a public transform called bullet spawn. A public float called projectile force that's going to be equal to, let's do 500. And a public float called fire rate, which is going to be exactly the same as what we did before. And then a private float called next fire time. Again, the same as what we did in the other script. Okay, we don't need start. All we need is update in this case. And what we're going to do is we're just going to, again, check if input.getButtonDown. Let's do fire 2 this time. Right click. And time.time is greater than next fire time. We are going to do the following. We are going to say rigid body clone RB equals instantiate projectile. The thing we're going to instantiate is our projectile. The place we're going to instantiate it is bullet spawn dot position, which is going to be our gun end again, and then quaternion dot identity, so no rotation. We're going to instantiate it as a rigid body. We're casting it to a rigid body because instantiate can return a rigid body. So we're going to store the new copy of the object in clone RB as a rigid body because we're going to want to use its rigid body right now. So then we're going to say clone RB dot add force bullet spawn dot transform dot forward, so forward from our gun end's position, times projectile force. Now, some of you may be wondering, why am I doing a physics thing in update? Shouldn't I be doing this in fixed update? Normally for physics we would want to, but in this case, because I'm just applying one single hit of force for one frame, there's no need to do it in fixed update, because fixed update, you use fixed update so that your physics doesn't get out of time with your regular update if your update is running at different frame rates, which it will be at different computers. But if it's only happening for one frame, it's always going to be the same. So it's fine. So in this case, and then we're just going to say next fire time equals time.time plus fire rate. And that's it. Super simple. We're just instantiating our grenade prefab, adding force away from the place it was spawned with projectile force, and then resetting our fire timer. So let's go in here and go into the editor, and we will assign our projectile once it's done compiling. So in this case, we're going to go to assets and, oh, actually I can't do it this way. I have to actually drag it in. It's going to be in prefabs, projectile, boop, drop it in there. So we can see we're dropping it in as a rigid body, and then bullet spawn is going to be gun end. Do it right that time. And now we can test. And so, boom, boom, boom. We can have lots of fun exploding all the things. So let me take a couple questions real quick, and then I will show you the explosion code that's actually doing the physics stuff there. Let's see how we're doing. Okay. All right. Time. Okay. Everybody's having a hard time typing. Yeah, you have to type time space time space dot space time because it thinks you're trying to spam the chat with links. I'm doing time.delta time is the time since the last frame was rendered. In this case, time.time is the time since the game started in seconds. Yeah. There we go. All right. Cool. So let's look at this explode script real quick. I'm not going to write this one out. I'll just walk you through it. So here on the projectile, we have a script attached called explode, right? The projectile is just a sphere with a rigid body and this explode script on it. And what the explode script does, it's also pretty simple. It has a particle system that it spawns, which is those yellow particles. It's got a public float called blast radius. This is a radius around the hit point that it's going to do its explosion thing and add force to things. It's also got damage. I set the damage low to 1 so it doesn't just make the man disappear. And then we have a private Boolean called explode. So in this one, I am actually doing the physics in fixed update because it might conceivably happen over more than one frame. So what we're doing here is we're saying on collision enter, right? So when the projectile object collides with the floor or the man or whatever it collides with when we launch it, we're going to call explosion particles.setActiveTrue. Now notice I didn't instantiate the explosion particles. Let's look at the prefab. They're actually a child of the projectile. They're just there as a child. They've got play on awake enabled, and they themselves are not enabled. So we're just going to enable them to play the particle system. And then what I'm doing is I'm saying explosion particles.transform.setParent null. So they start off as a child, but then they stop being a child when we call setParent null, so that they will not be deactivated when we deactivate the sphere to destroy it when we trigger the explosion. This is something that people run into problems with also with playing sounds. They'll have like a sound that's supposed to play when something hits it, but then the thing immediately gets deactivated and the sound gets cut off, right? So unparenting it will allow the particle system to hang out and play while the other thing disappears. Then we're going to set our explode Boolean to true, right? So it's time to explode. Now, I'm just setting it to true here. I'm not actually calling like a function called explode. What I'm doing is I'm just setting it to true and then waiting until the next fixed update to actually explode, so that the explosion will happen in step with the physics time. So fixed update runs every 50 times a second. It's always the same. And so in this case, we're going to wait because the frame where the explosion got triggered and the next fixed update might not be the same. So we're going to wait until there's a fixed update so we can do physics stuff. And then what we're going to do is we're going to use a function called physics.overlapSphere. So physics.overlapSphere is similar to Raycast in that it's casting an invisible shape in the scene and using that to get information about physics objects in the scene. So in this case, we're using physics.overlapSphere around transform.position, right? The position where the game object was, the sphere in this case was when it exploded, and we're casting the sphere in the range of blast radius. So in this case, it's 1 unit. So it's 1 unit around the sphere. And then what it's going to do is everything that the physics overlap sphere overlaps with is going to be stored in an array of colliders called hit colliders. So an array is a collection of things. You can have an array of whatever you want. So we're going to store those in there. And then we're going to use a for loop to go through each of those colliders in our hit colliders array and check on them and do things with them. So we've got for in I equals 0, I is less than hit colliders.length, I++, right? So we're going to go loop through the array and check each element. Excuse me. And then we are going to, so the first thing that we're going to do for each element, we're going to check if hit colliders, this collider, right, I, this index in the array, dot get component I damageable does not equal null. So I damageable is something we haven't seen yet. This is what's called an interface. Now, if you only wanted to damage something with an enemy health script attached, you could just replace this with enemy health, right? I'll show you the interface approach here because I think it's kind of cool, and it allows us to damage all different types of objects and to damage them in different ways. So if you remember, we've got these boxes on the ground, right, that turn red. If we shoot them with the gun can move them, but it doesn't do anything else to them. The gun is looking for an enemy health component. If we explode them with the grenade, they turn red because they actually are damageable, but they don't have an enemy health script attached. They have a box damage script attached. And I'll walk you through that in a moment. So in this case, we're saying, so we're checking to see if there's a damageable script attached. Then we're going to say hit colliders I.getComponent IDamageable.damage, right? So we're just passing in our damage function. We're calling our damage function. We're passing in our damage. In this case, it's 1. And we're passing in the position of the collider that we hit if we want to like spawn some particles, for example. Then we're going to say hit colliders I.getComponent rigid body dot add explosion force. And actually, really what I should have done here, let me rewrite this a little bit because this is like just to be kind of clean. I should check to see if rigid body is null. I mean, I could put in IDamageable that it requires a rigid body, but if I made something damageable and forgot to put a rigid body, I get an error. So let's just say, let's just check to make sure that there is a rigid body there. That's a little cleaner, a little safer. Okay, so then we're going to add explosion force. We're going to add 6,000 units of force at transform.position in a radius of blast radius. So add explosion force just basically is a physics function that allows us to do explosions, and it has a radius which we're going to use the same blast radius for. And then we're just going to call this .gameObject.setActiveFalse, right, which is just deactivating the sphere, the grenade. So once we've got all that stuff working, let me just make sure my change to the code worked. It should work. Boom, boom. So much fun blowing things up with physics. All right, let me take a quick look at the chat. How am I doing on time? Oh, pretty good. Okay, and then I'll talk about the interface thing. Let's see. What do we got? All right. Hydrasin. Yeah, there will be a repeat of this. There'll be a recap, a video. Actually, there already is, but this is like a slightly updated version. Does time.time ever overrun? Man, I don't know. I think it would take a while, though. I don't know the answer to that. Yeah. Oboe shape answers. I guess it would be bound by the constraints of a float type. Yeah, I think that's probably right. Hydrasin asks if the projectiles are being instantiated or is there an object pool? They're being instantiated. In a production example, an object pool would definitely be more efficient. I just don't have time to get into object pooling here. But yeah, in a real game, instead of instantiating them, we would just instantiate a pool of them off screen and then just grab the one that we want and then just reuse them so that we don't have to instantiate, because instantiate is a little slow. All right, people talking about the length of the universe. Not touching that. Taraka asks, isn't it efficient to use too many GetComponent calls in updates? Yes, it is. But in this case, we're talking about an explosion, which it's only going to be... Realistically, this stuff is only going to get called... I think it's only going to get called once, actually, because the game object is going to get set active to false. So it's really not that expensive. It's not like it's repeatedly getting called in update. If you were calling GetComponent every frame, you should cache that value. But in this case, the thing is being deactivated, so nah, it's fine. Oh, C-Stracken asks, why does laser pew when stopping game? The reason is because the default mapping for laser is the control key. So I'm going to hit control P to stop the game, and it's shooting the laser. One last laser. All right. Hydrasin asks, will the topics covered here be true for online multiplayer games? Generally, yes. You will need... You should look at Mike Geig's Merry Fragmus session. He uses raycast shooting in there, and it's online multiplayer. It's simple, but it does cover the basics, and I'm not sure about raycasting over a network. I know that one of the challenges with it is that you have to do like prediction or account for time lag and latency, which can be tricky, but can also be overcome. All right, Guru NYC. What's up, fellow NYC person? I'm also an NYC. My experience with animation to ragdoll is 0. I've actually never done it before. It would be nice to have in this. And somebody else suggested that as a topic, so maybe I'll do a thing on it. I know there's a ragdoll wizard in Unity that allows you to set up ragdolls, but I've never actually used it myself. Okay, people talking about 1,000 billion years. Yeah, all right. For stuff like missiles, man, I just don't know about networking and physics. Theoretically, it's possible, but I don't know how to do it. So that it's a little beyond the nature of this session. This is not a networking session. But we do, I know we've been promising it for a while. We do have content coming on the networking tools. It's just kind of a beast of a subject. But Adam Buckner has been working hard on some stuff about the multiplayer lobby. And then I think there's like a networked racing game that we're going to ship and some other stuff that'll be coming sometime very soon that'll cover the networking tools. Okay, as GM Liquid Media says, in the Christmas multiplayer, the Raycast is just on the client side, so no prediction. So yeah, it's fair. Getting networked, dealing with lag in networking is kind of like the big problem, or one of the big problems. And so I know that, like, I think one way to do it, this is getting off topic, but it's kind of interesting. One way to do it is that the server is always recording to like a buffer the position of every player. And then let's say you have a ping of 30 milliseconds, right? What it'll do, you shoot, and then it'll check to see if 30 milliseconds ago the enemy that you were shooting at was in that position. Then it will apply the damage. So it actually looks back in time to see, would that shot have hit, and then will apply the damage. So they're like constantly recording a buffer that they can look backwards into, probably like a buffer like a second long, so 60 frames or 90 frames or whatever, and then check in that frame. The key with like getting that networking stuff is not that it's actually accurate, it's just that it feels fair and feels like it works, so it's all trickery. But yeah, it's kind of amazing that people have been doing like network shooting games for years and getting it to work on all kinds of slow connections, which is pretty impressive. But that's, you have heard basically everything that I know about that at this point. Okay, so let me just walk you through the interface aspect of this. So if we look at our box, one of our boxes here, let's look at this one. This box has a script on it called box damage. And if we open it in MonoDevelop, super simple. It's just getting the mesh renderer, and then it has a public function called damage that, when it's called, turns the material color to color.red, right? So the reason that this works is because box damage implements or subscribes to the iDamageable interface. So what is an interface? An interface is a code contract that says, for something to be considered an iDamageable, here's our iDamageable script. For something to be considered an iDamageable, it has to implement all the functions listed. In this case, there's only one, which is called damage. So it has to, for something to be treated as an iDamageable, it has to have a function called damage that takes an integer argument called damage, which is the amount of damage, and then a vector3 argument called hit point, which is going to be the point that the object was hit. So box damage has a damage function, and therefore is allowed to subscribe to iDamageable. If we look at our enemy health script, which I skipped over, we can look at now, it also is iDamageable and also has a public function called damage, but does something different internally, right? So in this case, it will set current health to minus equal damage, right? So it's subtracting from the total hit points and then checking if current health is less than or equal to 0. It's going to call defeated, and defeated is going to set the game object to inactive, deactivate the game object, right? So, and here I turned it off for the earlier part of the demo, but we can turn it back on now. We could instantiate some unique particles for shooting the man as opposed to shooting the boxes, right? So here we're just going to instantiate hit particles at hit point, right, which we're passing in here when we shoot it. So let's do that for fun. And what we need to change in our raycast shoot script now is that instead of looking for an enemy health, now we're just looking for an eye damageable, right? So what this allows us to do is by saying, okay, we're just trying to shoot an eye damageable or blow up an eye damageable with our grenade, we can now search for multiple different types of scripts and treat them as basically the same, because for our purposes, they all are the same in that they all have a damage function, right? And so we can just say, okay, damage script, any eye damageable, damage script, dot damage, and then deal the damage. And then internally in the implementation of the damage functions, we can do different things that are appropriate for that object. So it's a pretty cool, pretty useful thing to be able to do. If you want more on interfaces, I did a session called Building AI with State Machines and Interfaces, which is an hour-long session about making a enemy AI that uses an interface as well. And I talk a little bit more about interfaces there. And I'm pretty sure we have a scripting lesson on the Unity site on the Learn site, unity3d.com/learn, about interfaces there. So now let's save this. And now let me just make sure my maze character yes, he has a hit particle system attached to him. So now when I shoot him, I should be able to play unique particles. I can't really see. Let's see. Yeah, you can see the orangish, brownish particles being played there. And then when I shoot these, oops, I'm like blocking myself. I can now play the default particles and turn these guys red. So just a kind of a useful way to build some flexibility into your system. And we could use this to say we want to shatter the boxes and play a unique shattering sound effect, and the enemy plays a death animation, and do all kinds of polish that we want to do by calling that same damage function, which has a different implementation in each class. So, yeah, that is the content for today. Hopefully it was useful for you guys. Thank you for joining me. I am going to hang out. I'll take some questions about this, and we can answer a few questions about some other stuff in the chat. Thanks.